Okay, 5.1 here, multiplying and dividing rational expressions. So rational expressions is referring to ratios, which are fractions. And so these are essentially, we're just multiplying fractions that have variables and exponents and things like that. So just remember, when you're multiplying fractions, we're going to multiply straight across. So numerator to numerator, denominator to denominator. And then reduce the answer. You can reduce it after multiplying, or you can do some cross-cancel reducing beforehand. And I tend to prefer to do that beforehand because it makes things a little easier. But if you don't notice, it's not a big deal. So let's see both here and see which one you prefer. So if we multiply straight across, if we're going to reduce afterwards, here 2 times 5 is 10, and 3 times 6 is 18. And now I know that I can reduce this fraction since they're both even. I can divide them both by 2. So we get 5 over 9. And that is the most I can do. 5 is a prime number, so there's no way to reduce this further. Now, if I do some cross-canceling ahead of time, I can look at this all as one large fraction, essentially. And so I can divide, okay, I see a 2 and a 6. Those are both even. I can divide those both by 2. So I get 1 and 3. And now if I multiply across, 1 times 5 is 5, and 3 times 3 is 9. So we get to the answer right away after multiplying. So it really just depends on the fraction, but I tend to like to cross-cancel reduce ahead of time because in most cases, that makes my reducing after I multiply, if there is any to do, a lot simpler. But let's practice this. We're going to multiply these fractions, simplify the answers completely, and check expressions for GCFs. So if we have polynomial expressions in our fractions, checking for a GCF first can help us cancel things out. All right, so first of all, I'm going to look across the denominator here and try to cancel some things. So the x to the third power, and then I have an x to the third power on the bottom. Those are both going to cancel out because 3 minus 3 is 0, and x to the 0 is 1. Now I have some even numbers and some 11s and things. So 22 and 11, I can cross cancel there. Divide them both by 11. I get 2 on top here and 1 down here. And then I can, either way works, I can cross cancel this 14 with either the 2 or the 6. Doesn't matter, so we can divide by 2. I'll go ahead and use the 2. That'll get rid of it all the way. So I get 7 here and a 1 here. A lot of cross-canceling on this problem. If you don't like doing this because it looks a little messy, you can always just do it afterwards. 6 times 1 on top is 6. 1 times 7 is 7, and there's our answer, 6/7. All right, example B. Now, this polynomial here, this binomial, has been factored 2 times x plus 1, which was nice because now I can see that x plus 1 will cancel out with the x plus 1 down here. And if I factor this 4x plus 12, I can take a 4 out. So that'd be 4 times x plus 3. Well, that'll cancel out with this x plus 3 down here. So I just have 1s on the bottom of each fraction now. So 2 times 4 on top is 8, and 8 over 1, that's just 8. So my answer there is 8. All that stuff canceled out. And lastly, example C here. So do something similar as what we saw in the last problem. We can factor this 10x plus 5 by pulling a factor of 5 out, a GCF of 5 from both of those terms. So that's 2x plus 1. Well, that's nice. I can also do that on the bottom here. I can take a 2 out, and that gives us 2 times x plus 2. And then we can see, well, this 2x plus 1 will cancel. This 2 will cancel with this 2 up here. So that entire second fraction is reduced away. And we're left with 5 over x plus 2. Right, 5 times 1 on top, and then just the x plus 2 on the bottom. That would have been a lot harder to reduce or simplify after multiplying because I would have had a larger, like a trinomial on the bottom. And so doing it ahead of time can really help. All right, let's talk about dividing. Remember, when dividing fractions, we have to flip the second fraction and multiply. So flip the second fraction and multiply. You might also know this as multiply by the reciprocal. All right, so we're going to flip that second one. So we have 1/2 divided by 1/4. So to divide by a fraction, we flip it and multiply. So we're going to do 1/2 times 4/1. And again, we can cross cancel ahead of time. This is a 2 and a 4, so that'll cancel out to a 1 and a 2. Divide them both by 2. So we just get 2 here. 1 times 2 is 2 over 1 is 2. Which makes sense because there are 2/4 in each half. All right, 8/10 divided by 1/2. We're going to flip it. So 8/10 times 2/1. And again, we can do some cross canceling here. Cross cancel the 2 with the 10. We get 5 and 1. So it looks like our answer is just 8/5. All right, let's practice with some more complicated fractions. X to the 4th over 3 divided by x squared over 9. Again, we're just going to flip the second one. Make sure you do this before you try to do any cross canceling because your numerator and denominator switch places. So if you try to cross cancel first, you're going to cancel things that shouldn't be canceled. All right, so right away I see the x squareds on the bottom will cancel out 2 from the top here. So I have x squared on the top. And then 9/3, that's just 3/1. So for the answer, I have 2 times 3 on the, x squared times 3 on the top. So that's 3x squared over just a 1 on the bottom. So it's just 3x squared. For example, B, we're going to have to do some factoring, I think. We can pull a 5 out of this one. So that's x plus 4. And we can do that on the bottom one as well. We can take that out 2 and x minus 1. Notice I'm not cross canceling there. I'm just factoring a little bit. I got a little ahead of myself, I will admit. But that's okay to do before you flip and multiply. Just make sure you're not canceling anything ahead of time. So 5 times x plus 4 over 2 times x minus 1 times, and then we're going to flip that second fraction, x minus 1 over x plus 4. So now we can see the x minus 1s will cancel out. The x plus 4s will cancel out. And we're left with 5/2. All right, this one looks a little more complicated, but it's probably not. Let's go ahead and first, let's just go ahead and do that first. Let's see if there's a GCF we can take out here. Nothing in the first one. These are just monomials. But in the second one, on the top here, this binomial, I can pull out a 2xy. And that will leave 3x plus 4y on the top. So now when we flip that second fraction, we've got 2x to the 4th y squared over 3 times 12 over 2xy times 3x plus 4y. All right, now we can look for things to cross cancel here. The 3 and the 12, that works. That'll turn that into a 4. Okay, now this 2 and this 2 will cancel out, and I can take this x and y off as well and just reduce these exponents by 1 each. I think that's it. Let's see what our answer turns out to be. So on top, we've got x to the 3rd y times 4. So that's 4x to the 3rd y over 1 times, and then just 3x plus 4y. There's actually nothing else I can simplify here because this denominator is a binomial, so I can't cancel that y out because I'd have to do it from each term, and each term doesn't have a y. So this is all I can do there. 4x to the third y over 3x plus 4y. So treat these just like regular fractions. You just have to remember all the exponent rules and how to divide and multiply with powers. But other than that, the process, the math rules are the same as multiplying or dividing any normal fraction.